welcome back to 380. This is going to be probably quite a few videos, but straightforward sort of stuff. Trying to simulate work here. Going to begin by uploading a fairly complicated assembly here. It's fairly old school. It's labeled rail transport hanger. It's from an old textbook. I believe it's from the 1920s, 1930s, with some sort of modernizations. There's a rolling element bearing or two in there. So it's a kind of a much modified, reused thing. Using this in this video or series of videos as a sort of an effort to lightweight we'll call it I think it's the hanger itself. We're going to see what it's called. Wait for it to process and go ahead and open it. Now, going to be doing a lot of simulation here. The goal here is to try and do this as smoothly as possible. We can see all the placed parts here. There's lots of them. What's going on? So let's have a look. So some fasteners, that'll be maybe a problem, maybe not. We'll see how that goes. They're helically, they're modeled, the threads are modeled, so that could also be a problem. You can see here, there's some ball bearings in there, so there's quite a lot of stuff going on. I'm just having a look here. One thing I'm interested in is this part. The hanger is what we're going to call it. Let's isolate that. The reason I'm looking at it in this view, which again was Control 8, Control 6 to go back to normal, we can see through. What I'm mostly interested in is stuff like this. Sometimes a step comes through perfectly fine on one side, for example here, a fillet, and on the other side, not so great. So we're going to fix this up. So we'll spend a little bit of time prepping our part for simulation, and then we'll get into simulation in this video and maybe do a first pass just to see what's going on. So that's the goal. I have some, you'll hear me rustling paper in the background. I've tried running this a couple times just to get the right loads and all the rest. So we're going to use this video to set up contacts and all the rest. So step one, to make our tree a little bit more compact here by creating a group, sorry, off screen, and I'll just rename as step place, something like that. So if we want, we can see these parts. They're all, just unisolate to show everything. They're all loose. So if we press Shift N, we can see all these components. Now, right now, I'm only interested in this pinky one. If I want, I can recolor this because I'm going to be looking at it a lot. Yellow, no, there's not a big yellow. So what I'm going to do first is kind of joint it up a little bit. And who doesn't like blue? We'll joint it up in a way that's quite easy and convenient for us. So we'll do moving and non-moving. We'll fix up that fillet and maybe do a first pass with the mesh and all the rest. So let's just create a sort of a beginning thing here, just to get everything organized. For those who are wondering what I'm talking about, I can drag all this stuff. I'm going to lock the hanger to the parent, which is the assembly itself. This is the thing I'm interested in most. And if I want, I can go ahead here and create a sort of rigid group of all the unmoving parts, hide that stuff and all the rest. So we'll go through a few things here, how to just get set up. This will be our first video. The wheel is going to be moving. That's bearing. It depends how you want to set it up, but I'm going to stick that as part of the wheel or the roller, however you want to see it. The stud will definitely be going with the hanger. So what I'm going to start doing here is creating a, if I can press the right button, What I'm going to start doing here is creating a sort of a selection set. So just to make a point about selection sets, we'll eventually make this into a rigid group. So you'll notice now you have selection sets available up here, and when you hover you get two options. One is to select that selection set, so if you notice we can now select it easily, and another one is to add or update. So it'll give you a warning, nothing selected. So what you have to do is start by selecting and then add to it. So hovering here, plates, no. These are all bearing, these are all fasteners are part of the wheel. That's locked. That's the fastener at the back. This guy is a little grip screw. And that's the lifting ring. Why don't we just make them all part of that? There's our selection set. So now if we select, see they're all selected. And why would we do this? Well, one way is we can go ahead here and now rigid group them. Now they don't get pulled. The other advantage of this is we can select them and press V, which hides them all. That means this can now be rigid grouped in its own way. So we can go into assembly, rigid group, say OK. We can also create a selection set here if we wish. So let's create another selection set. So we now have, we have two. That's our first, which is hidden. That's our second, nothing selected. Let's go ahead and select everything and add to group. 253 things. What is that? So let's just select only components, not bodies. This time we have 31 components, and we'll add that to our selection set. That's perfect. So now we can select this if we wish and hide it and show it. It's still movable. So what I'm going to do is one last thing. I'm going to, because I've included the bearings in this set, which is not completely correct because the inside is attached to this and so on and so forth, but I'm not going to be jointing this up. I'm just trying to get it right. Why don't we just rigidly connect this? It won't be rolling. We won't be having any function here, but we're just going to be interested in doing some simulation here. So pick the wheel, ground the bearing. That should stop us pulling everything inside, and now we're ready to go. So let's turn everything back on. Another way to do this, to make sure you're seeing everything at once, right click at the top, show all components, and show all bodies. That makes sure everything's visible. For us, we now can go ahead here and start working on our one part. I'm just going to make a point here about how to kind of get a feel for simulation. We can, for example, we're going to be worried about things like threads, which are modeled. Maybe also sort of extraneous parts of fillets, all that sort of stuff. The goal here is to try and simplify this so that our simulation runs smoothly. We see this problem already. So some corrupted fillets come in with the step. That's okay. And we have this guy, which is, yeah, threaded underneath. So we want to have both of these parts in here because this is going to have an effect on the simulation itself, because our load is going to be on this, whatever we're calling it here, stud. So we want to be as realistic as we can without running up the simulation time. So this is our goal. So let's just have at her. There is something missing here, which is what this is hanging on. So we'd like it to be fairly realistic through the hanger. This is actually attached to a pipe, and this little screw goes into the pipe. So that's our plan for this time. So we're already have a little bit on. So first, let's just try figuring out how to do the simulation. Strangely, let's do that first. Static is fine. It'll recolor, not a nice red. Now we definitely don't want to simulate or even run a mesh on this whole assembly. That would be total insanity. So what are we mostly interested in here? So I'm gonna go ahead here and try and figure out what things are essential, what are not. So we can do a simplification. We're gonna first get rid of probably this whole moving part, I would say. So let's see if we use selection sets again. Oh, they're there. That's not the one. So that's what we want to get rid of. Let's see if it goes well. Interestingly, usually we want to select what we want to keep inside of the simplification routine or environment. Oh, there it is again. So let's pick what we want. And then maybe we can right click on those. So we want to, there we go. Remove all except selected. So what we're going to be doing here is trying to replicate that load. Now, the other question is, what about this? The lifting ring might be having a small effect at the top, basically keeping this hole open, but it's going to be a loose fit and probably not going to be too interested in the effect of this. So let's also remove this. Lifting ring is gone. Now, of course, this is not removing it from the design. This is just removing it from the simulation. Unfortunately, we do need this screw because it's going to be kind of jammed into a pipe, which we probably have to model. So let's say we're happy with that as is. Although, what about these threads? Let's try removing a thread right now. So maybe, can we remove faces? Let's try that. See if it just takes it away. Oh, it does. Nice. This is kind of now in the way. So let's just hide that. See if we can remove these faces. No. No. No, that doesn't work. Just undo. What if we pull like so? Interesting. It's going to try and, what does that do? No, it just gets rid of everything. So we might have to fix this one up back in the design. Yeah, because it just goes right through to the whole thing. So we did well with our little screw, or did we? It looks a little small. Yeah, so we're going to have to take why don't we do that for all of these? We'll try and get rid of the model threads back in the design tree. We also have this problem. So let's go ahead here, go back into design. Let's finish simplifying. Design. Let's hide these guys so they're not in the way. And let's try doing this. So that's our first attempt. Let's isolate that. So we probably want to try. Oh, we've still got our select turned on here. Probably want to try and delete just the faces. Let's see if we can delete them like this. It does work, so that's good. That's good. Now I want to unisolate that. And I've got a whole bunch of stuff going on here. Let's turn on an inspection section analysis so we can see what we're doing. What about this internal stuff? Again, it's going to be right in there, and this is going to be just extraneous, I think. So we can see we've got a delete here. Wonder if we could just keep going. It's not bad. There's other ways to do this. So let's try a different way. So we can also go in here to modify, simplify. There is a simplify in here, and we can maybe see if we can get some of this stuff. Oh, nice. So that gets it all at once. That's quite good. So we've got two options here. Maybe we can just edit these at our leisure. So maybe hide that guy. We can maybe add our other edge. So we want to keep the inside of this one. So let's just add these three. Oh, perfect. That does work nicely. So we've got an overlap. This will basically just stick these two parts together and make them into one. Not worried about the lifting ring. Let's go and do these in here. So I'm going to hide selectively here. So let's do the, we can hide the stub shaft first, or the stud. Get 3 of these because I want the minimum here. That works. Hide the nut and show the stud. If I've been careful, then I can get in here and get these 3. Should work. Show everything. It's good. Now we see here there's a kind of a modeling issue here. Excuse me. We have this strange face in here. It's not a big deal. Excuse me. It was actually modeled like this, sharp edge. We'll keep an eye on this for unexpectedly high stresses right in here. So we're going to keep an eye on this corner in here. But for now, let's just leave it to keep it simple. We'll just see if we need to modify it. Out here we have a fillet. We can simplify that back in the simulation environment. But everything else is looking okay here. Let's go back to simulation. We haven't done a mesh or anything, so it just updates automatically. And that's looking not too bad. Let's try a mesh. Just click mesh visibility on. It'll go ahead and mesh. We may get an error. There it is. Now this is really great. I have to say, like, it gives us errors and shows us where the errors are, so we can go and fix these. So look what this says. Surface meshing, description geometry error. As far as I know, and I think I'm correct here, when Fusion meshes, it meshes the surface first, and then kind of propagates the mesh through the part into the 3D part, so a solid mesh. So this is a mesh error right at the start. So there's something wrong with the surface, and no surprise, it's this guy. Overlapping surfaces is a big no-no for meshing. So we've also got an error further up here. Same thing. I wonder what it's pointing at. So something up in here is not happy. So let's just keep an eye on, try and fix this one first and see how it goes later. So let's go back to design. Fix this part. We can do everything in the top layer. We're interested in an ultra compact history this time. Let's turn off our analysis and isolate the hanger, which is what we're going to be doing a lot of work on. So isolate. So this is our problem area here. Now one way is just to try and fix this, various approaches. For me, I'm just going to figure out what this, see if I can sort out what the radius is on this fillet. Look for an easy one. 1/8. Write that down. See if we can find other values. How about this guy? That's a 1/4. Nope. I can't do my own math. That's an 1/8 too. So how about this? Maybe we can find it here. That's something else. That might be an 1/8. Oh, radius 1. Let's leave that. So leave that 1. So these are larger radiuses. Sometimes we're lucky we can get a value by picking it. If it's just a straight fillet, this guy, that's also 1. How about this? Well, that's part of the thing, 3.25. What about this? That's a complicated one. Let's try and leave this one. That's an 1/8. So they all look like they're 1/8, the things that we're interested in. So let's see if we can delete these. we're going to run into problems. Probably up here, this strange little shape, little dart faces, and I am going to try and delete these as well. Yep. So I'm going to try and fix these all at once. So let's see if we can, maybe the simplify is better. We can add one here for remove faces. We use that to simplify the inside of that grub screw. So I'm going to actually do it differently, make a new one. A new feature here. So simplify, remove faces. Let's see if we get what we want here. Oh, nice. That works. How about this? That's not showing me what I want to see, I suspect. Oh, maybe. Let's try deleting. Yeah, we're gonna run into real problems here. It was able to delete these, so it'll actually do what it can, but then kind of gave up. Let's try that again. If we go in here, we see a yellow, like for a error state, or at least problem state. Let's just take what we can get. So this shows that it's feasible. So we could just get rid of the easy ones. No, that's not working. How about some of these? Maybe. No, it didn't do that last one. So I'll shift select that. I'm just going to go with these two easy ones, that's fine. Next, let's try and figure out how to get rid of this. I'm just going to try delete. Nope. So for those who are wondering why is he doing this, this is a good, kind of a great problem to be sorting out right now, to be honest, to see if we can get rid of things. So that's not happening. Now we've got a real problem here. So what's happening, for those of inquiring minds, it can't heal up the solid, it's so janky. So what, is there a nuclear option here we could use? Yeah, there is. So we've got a functional fillet on one side and a completely non-functional fillet on the other side. The nuclear option here is actually just get rid of the entire half part. So before that delete, that kind of worked. Simplification. I'm going to come back over here. I'm actually going to split this part. So I'm going to go into this component. I'm going to split body, this body, splitting tool. I'm going to use the origin if I can see it. Actually, let's not use its origin, let's use this one. We'll use the origin inside the component, it should be the same. Split that guy. And if you want to be thorough, which we probably do, I'm going to actually delete the side that I don't like, that body one in my case. So remove or delete. Notice what we get here. So if you use a delete, it might go in there and adjust the timeline. For us, it's not a big deal, but for us, let's just use remove instead. Then we have a mirror body. Let's use the face of the body to do the mirror and join. We'll give us one part again. And then we have a fixed up fillet. Sometimes you'll see little extra bits. We'll see if this has an effect. So for example, we have this little edge now. Sometimes you can just press delete and it will, if you're lucky, get rid of it. If you're not, it won't do anything. No. So let's do a simplification now. We pulled our history back. Maybe we can try this. Oh, it's looking a little better. A little miller. Oh no! It's back. What's going on? Well, the simplification is pulling some history around with it. So this sometimes happens. It's part of the kind of vagaries of CAD. Let's try it again. The simplification of notice remove faces does sometimes do that. Keeps a cache, I believe. Now maybe we can delete one of these. Oh, nice. Tidy. It also tidied this up. tidy up at the top. Let's edit that. So it stays open, but we can add maybe these two guys. That's good. And then while we're at it, why not just get rid of this guy as well? And that's still working. So you'll notice I'm doing this a piece at a time. I want to keep this as simple as possible. These larger fillets, one, and this one down here, which is looks like it's functional for how we're going to join the parts. Geometry wise, I'm leaving. Say okay to that and go back into simulation. We're going to go ahead here and remesh. And it does go. So there we go. Everything seems good-ish so far. Now I'm keeping in mind that I have removed the mesh, sorry, not the mesh, the fillet here in various places. So when I run it the first time, I'm going to have a look about where my high hot spots are, where my low safety factors are. This is a really loose mesh, but we have some small work to be done here, which is we need to put in a piece of pipe and then run our contacts. So back to design. Let's just stay in, no, let's make a new component. So up at the top level, make a component. We'll call it pipe. And because I don't have a number here, I'll just give it an underscore. From bodies, activate. We don't have any bodies, so let's say okay. Let's draw on this. Actually, let's use our origin here. So I'm gonna hide, I don't know what origin that is. So I'm looking for the ZY, ZXY, what's that? What I said? New sketch. Now, I've lost the visibility of some stuff. There it is. So, and I think I'm still isolated here. So there's our parts. Sorry, it's just getting a bit out of control. Let's do a guide. Don't know where the center is of the pipe, essentially. So let's go ahead here and do a bit of a projection. So let's project the inside surface of the hanger into our sketch. It'll give us some janky edge if we do it that way, so let's undo. Let's try again. So I don't want to have projections of the whole surface. It'll give me these holes, just the edge perhaps. So give me a solid edge. Perfect. X that so it doesn't contribute accidentally. And then let's have a look. I can right click here and isolate my soon to be component. Let's do a circle of some size. Let's try and align it. So we'll go for vertical over this origin, whatever it is. And we're going to have it touching the top, so tangency. So let's make sure we're getting what we want. There we go. And let's have a look at our other components here. It should be around here-ish. Let's put a dimension to that. So I want it to be just touching the top of this, the tip of our screw, of our set screw. And we're quite close to something here, 2.375 almost. Almost like it's planned out. Finish the sketch. Do an extrude. Make sure you're still in the pipe component. Extrude. Notice that we have an option here for a thin wall. So there it is. So do a thin wall, thin extrude. I'm going to go symmetrical. Measure across the length and call it, I don't know, say 4 inch total. And let's put the wall thickness. We're not going to be really concerned about this part too much, but let's give it like an 1/8. Say okay. There's our component. Go back to the top level. So we have a new component. If we go into simulation now, we should see it keeps it. The mesh is not in there, so I'll just remesh. That's a coarse mesh, but it's there, right? It's a nasty mesh, but whatever. It's kind of touching. The last step of this video on this side is part of our prep is to have a look at what we've got for mesh. Some nastiness in here, that's not so great. Got a little dart face here. Whew, should fix that up. We've got some touch. We'll make sure that it actually closes up right. We have a potentially overly complicated nut here. But you know, it might not be too bad. I can look inside model components and hide it. Really sort of very rough mesh through the stud, but it's meshing, so that's good. It's a good start. Now, last thing, let's do auto contacts. 0.1 millimeters. It's inch, it doesn't matter. Like, we're just after close size. We should be seeing some now. So we look at contacts. When you're here, we'll edit, and you can see them all. Now, I'm gonna go through these one at a time and kind of carefully look at what's going on. Okay, so this is the threaded little grub screw, as I call it. That's bonded. We basically want it to be the same part. That's fine. Where's our other one? This is not correct. Right, so when we pull, we're gonna have a load on this. When we push down on this, this fastener may come away, right? So it might actually bend away. So we only have a pivot around this part of the contact. So I'm going to change that from bonded to separation. This will allow a bit of sliding and separation. Leave it as symmetric. Next. Same argument here. As we push down on the stud, we might actually pull away from that surface. So we want to do a separation. If I could get the right thing. There we go. Next one, bonded. Again, we might deform the shape of the hanger around the stud. So we could end up with separation or sliding. But we could also call it rough. So it's up to us how we're going to do it. But it's trapped inside. I'm going to go with separation. This is a question. We're going to keep an eye on this one as we go through. Next, this is bonded. That's the threads. Next, after that, this is just basically a trapped piece of pipe inside the hanger. Let's call that rough. So it won't slide. And last, tiny. This might actually be like if you screw it hard enough, and probably somebody with a wrench will, it'll actually be almost bonded as if it was glued. So let's leave it at bonded. Say okay. Let's have a look at degree of freedom view. Now nothing's fixed because, oh right, we haven't set up our constraints. Constrain the end of the pipe. Now again, not ultra realistic. This pipe is not going to be clamped like this. We should make it much longer or something, but let's just go with this fixed. We're not very interested in the pipe. Now let's see our degree of freedom. Everything's either fixed or potentially fixed. Potentially fixed usually gives us a, let's remove rigid body modes to make it look for unexpected movements. So it'll dampen that out. So there we go. Everything's looking okay. Let's put a load on here. So the load is going to be a bearing load because we've got bearings on here. And there's two of them, so let's just pretend that they're all one. Make sure it's pointing down, correct. And I'm going to put 500 pounds force downward. Maybe just pounds. And what do they want for pounds? Let's actually, we can't figure out what's going on here, so let's change the units to pounds force. There we go. And it'll do the math for us if we want. So we had 500 newtons, but I want 500 pounds force. Be a little careful there. So again, watch what happens. 500 pounds down. That's fine. We're still not passing our pre-check because our materials haven't been focused. Gonna go through here, gonna select everything. I'm not using stainless. I want to use 1050, I think. So AI SI 1050. Make sure they all update correctly. And yield strength is fine. We're now quasi-passing. It's going to give us a warning on degree of freedom. Showing some manual contacts might be a problem, but I'm just going to run this as it is, which is really rough on the mesh, which is fine. Actually, before we do that, let's just run our mesh one last time. Our mesh is slightly out of date. Looks fine. Tighter mesh now around the stud because we've got dealt with the fillets. So let's run it. And we're back. Let's have a look. Whoa, there we go. All I'm interested right now is seeing that it works at all, and trying for a little idea that maybe my contacts are correct. So let's have a look here. Nothing. There's some stress here, which we'd expect to see. That's all fine. Looks okay. Let's have a look at just, for example, stress. And right now we're under an ultra adjusted deformation. So if we look at actual, it's fairly small. Like, let's have a look at the displacement. It thinks right now like 0.1 millimeters. Again, we're not an inch here. Let's have a look at inch. Like tiny movement so far. That's okay. So 500 pounds force, which I used calculating rail lengths and all that sort of stuff. So, but let's just go with 500 pounds sitting on this guy, and let's look at our stress. We see our stress where we would expect. Imagining flow lines, it's going to be compressed most here as it comes around the corner and up. But let's make sure our movements are correct. Half, adjusted, well, basically 1. Adjusted 2 times and adjusted 5 times. The adjusted 5 times, you start to get calculation rounding errors coming in, so it's looks like it's disappearing. Looks like it's pulling away, but that's crazy. So what we should be seeing here is just it is in fact slightly pulling away here, but not on the back, just fine. So everyone's looking okay. Let's have a look inside. We kind of need to see through with a slice plane. We made this pipe 4-inch, if I remember that. Ooh. So let's go back to -2 inch. That'll put us right in the middle. Show the mesh. And you can, if you want, you can see vectors and all that sort of stuff. But for us, we should be able to see the movement just by showing it. And if we want, we can put a grid on here and all that sort of stuff. But for now, just say okay. You can actually see the plane that's made. If you turn off inside the browser, you can turn off the visibility of the plane. It still gives you the cutaway. To turn off the cutaway, just suppress it. Let's turn on the mesh. There we go. So we can see the mass meshed correctly, and we'll have a look at what we get here. So it's looking okay, apart from the fact that we have a really rough mesh, but on the whole, we're seeing what we want. And now that we've done all this work thinking about it, got a safety factor here about 2 right here at the back. Now this number is not going to be reliable because we don't have a good mesh, right? So this is not safe number. But for now, we've got it set up. That's our first pass. So not anything useful. It looks like a really bad game from the 90s, but for us, we're happy with that. And we're going to finish there. That's our first pass at our simulation here. Next, let's actually get to doing some lightweighting. Going to be worrying about this rib or sticky outy part. Over to you. Thanks for watching.